following Chalk Talk is brought to you by Isolite, the emergency lighting experts. Stay educated, my friends.
My hope is by the end of this Chalk Talk, you all can more properly select between a UL 924 and UL 1008 device than I can properly select the winners of March Madness outcomes. For anyone needing a little pick-me-up today, you can have plenty of peace knowing that you are significantly better, even if you filled out a bracket, than I am at it. So congratulations to you. Happy Thursday afternoon, everybody. I'm Matt Bird, the Eastern Regional Sales Manager, along with Greg Keel, our Western Regional Sales Manager. Today's Chalk Talk will be packed filled with great information on UL 924 and UL 1008 devices. And Evan Ackman, who runs our product development team, will be handling the call. So Mr. Ackman, the floor is yours, sir.
Thank you. And Matt can take solace in the fact that my randomly generated bracket is beating his. So it's a good month of March for me. As Matt mentioned, not at all. This month, we're talking about the difference between UL 924 and UL 1008 style devices. If this sounds like it's a refresher course, in one sense it is. We actually touched on this, albeit very briefly, when we announced our ELCD product line 18 or 19 months ago. So we covered it really as an afterthought to the products. And we also touch on this really in our inverter design courses, but I really wanted to just have one dedicated presentation to give you guys the idea of what these things are, what the code actually says they are, as well as some plain English definitions of them, as well as to talk about when they're required in an emergency lighting system. We'll take a brief trip through our product line to remind you of the products that we have that fulfill these needs. And then I also wanted to go through some line drawings, specifically of our ELCD 924, the UL 924 style device, the UL 1008 style device, and then a very special section that covers how to use UL 924 style devices with a generator, which is probably a more preferable way to achieve success, but we'll see that when we get to it. And I'll cut to the chase. One of the reasons why I wanted to do this presentation this month was because we intend to release an AIA accredited course for you and your customers in the coming weeks on this very topic. It'll be a little bit longer, but the idea behind doing a Chalk Talk as kind of the introduction gives us the opportunity to solicit questions from you in order to make sure that that presentation is as good as possible for you and your customers. In the spirit of that, obviously, this is a Chalk Talk, so you guys are muted so that we can stay on our time requirement. But if you do have questions, you can certainly hang out until the end, throw them in the chat. We'll give you a chance to ask those at the end, and we won't get off the line until everyone's taken care of. The first question that we're going to answer today is, what is an emergency lighting control device? We talk about them, and the general description of this is they allow fixtures that are controlled in normal operation to be overridden into an emergency mode where the lights are on at a known light level, regardless of the status of the control input. The idea is that if you have a zone of lights that are mixed between critical and non-critical fixtures, the emergency lighting control devices are the devices that change that mode of operation for the emergency fixtures so that you can be compliant with NFPA 101, the life safety code. Now, there are two different types of devices, and I've already alluded to them. There's UL 924 automatic load control relays, ALCRs is what you're going to see in the coming slides, as well as UL 1008, branch circuit emergency lighting transfer switches. And they operate very differently. They have different UL codes associated with them, and the applications in which they fit are actually pretty different. And so I wanted to just read the actual by the code definition of what this is, and then give you the plain English version because the code is kind of gobbledygook. I've also highlighted some things here that I think really make up the body and the critical distinction between these different types of devices. So an ALCR here is a device used to set normally dimmed or normally off switched emergency lighting equipment to full power illumination levels in the event of a loss of normal supply by bypassing the dimming or switching controls, and then to return the emergency lighting equipment to normal status when the device senses that the normal supply has been restored. So in plain English, my version of this, the thing that I fall back on is these devices override dimming and switching controls, and as such, they require a normally on power source. We'll see in the drawings that's really like the normally on output from the inverter, but they don't ever switch between two different power sources. They only ever engage and disengage that normally on power source. In contrast to that, we have the branch circuit emergency lighting transfer switches, the BCELTS devices. These are devices that are connected on the load side of a branch circuit over current protective device that transfers only emergency lighting loads from the normal supply to an emergency supply. The key word there is transfers. In the plain English version, these devices change the power source that actually supplies power to a fixture. It's going to be an emergency source in one instance and a non-emergency source in a different instance. The way that I tend to think about this is it converts a normally off source, like a generator, into a normally on source by switching between utility power in normal mode and generator power in emergency mode. Downstream, it could be treated as a normally on output. When are these devices required? This isn't an exhaustive list, but if you learn to sniff out these questions, then it'll serve you well to figure out exactly when you need these different device types. If you're using an inverter without switched output breakers, you're probably going to need a UL924 device in order to change the mode of those fixtures. If you're using some sort of normally off style emergency power storage or generation, whether that's a generator or a normally off output from an inverter, you're probably going to need a UL1008 device, although we'll show you in the diagrams that that may not be a BCELTS like we just talked about. The best summary of it, and the one that will get you the furthest, is if you have lighting zones that are mixed emergency and non-emergency that need to be controlled together, you're going to need some sort of ELCD in order to manage that transfer between those different modes of operation. Whether that's 924 or 1008, we'll talk about on the drawings. Now, the good news is, from the Isolite perspective, is we have products that do both of these things. We have our UL924 products, which are our ELCD 924, our ELCD-F, and our ELCD-FD. Those are all UL924 compliant devices. The options just give you fire alarms and dimming integration. The key of these devices is they're just built like tanks. They have a 50 amp relay, which is way oversized for the traditional loads that are going to go on it. And that relay is arcless. So the relay doesn't really have a failure mode. It's going to last forever. It's a million cycle relay solution. The other nice thing about these devices is that they're very modular in terms of how they mount, all in a single part number. If you look at our competitors' 924 compliant products, there's different model numbers based off of how it's intended to be installed. One model number goes in an outlet box in the wall. One model number, surface mounts on the inside of a fixture. One model number goes into a junction box. Ours doesn't have that. We actually have it such that the product is designed to go into all of those applications, all with the same part. And we achieve that via some cute snap tabbing of the plastic parts on the actual device itself. So it's very, very flexible device. Our UL1008 device is our ELCD 1008. The nice thing about that is there's no options. It's just one model number that includes everything. It's got dimming, it's got the fire alarm interface. It's really an all-in-one package. And that mentality really continues through all the way to the installation. Everything is internal. There's integrated replaceable fuses. There's terminal blocks inside of it. It actually solves some installation problems that exist in the industry with some of our competitors' products. But I want to just focus really on how these devices fit within the architecture of an emergency light system. And you've probably seen drawings like this before in Chalk Talks or in our inverter design course, but usually we focus on like one side of this drawing, either how the inverter operates or explicitly just how the 924 device or 1008 device operates. I wanted to have a drawing that sort of covered everything, all the way from the utility and the breaker panels through the inverter, out into the ELCD style devices, into the fixtures. Now, what we have here is one zone of lights that's split between non-critical and critical. Obviously, we have a breaker panel. Obviously, we have a lighting control. I've drawn this as a snap switch just for making the drawings simple. We have a UL924 device, that's an ALCR, and then we have an inverter. And let's just focus on the things that were highlighted in the definitions as well as the plain English versions. The idea for how this device works is it's going to short out or bypass that lighting control. So how does it do that? Well, in normal operation, obviously when this lighting control closes, the non-critical fixtures are going to operate in conjunction with it. But the other thing that's happening in that instance is the ALCR here observes that that's happened. It observes that it's not in an emergency through this sense line, and then it closes its relay so that the power that's derived through the inverter can then be passed out to the critical fixture, which then, keeps these devices working in conjunction with each other when there is no emergency. Similarly, the bypassing the controls means that if this sense line goes away, the ALCR is going to close its relay and just ignore everything that's happening on the switched input. It's bypassing the lighting controls, forcing that critical fixture to be on. That's how this device works. And then obviously it can return to normal operation when that sense line returns. Let's contrast this with the BCELTS, the UL 1008 style device. Again, same stuff here. We've got a lighting control. We've got one zone of lights. We have our emergency lighting control device here in the middle. But what we've added here is a generator, a proper normally off power source, as well as the emergency panel that it's feeding. Now there's some color coding here that I want to just drive your attention to. This is orange, which indicates that it's emergency only. It's a normally off type circuit. Red here is normally on. I'm calling that a critical circuit, which means that it's just always available, not just in an emergency, at all times. Now, the same types of behavior can be observed here. When everything's okay, when utility power is available, this lighting control, when it closes, again, obviously we'll be controlling the non-critical fixtures, but now nothing actually has to happen on the BCELTS because it actually just maintains a connection, a real galvanic electrical connection between the lighting control and the critical fixtures. It has that power source actually selected. And so this critical fixture is actually properly in parallel with the non-critical fixtures. Now, what's going to happen here in the emergency is when the sense input goes away, it's going to actually switch which power source is connected to the critical fixture. So remember, it transfers power. It actually takes this normally off circuit and converts it to a normally on circuit by changing which power source, whether that's the utility source or the generator-based source, is connected to the critical fixture. That's how the 1008 device works. And then it overrides the lighting control because it actually just totally pulls it out of the circuit. Now, this is a pretty good diagram that illustrates how those BCELTS devices work, but I will admit that this is good for a wiring diagram that goes into an instruction manual, but this isn't how the vast majority of big generator-based systems get architected. What actually happens is a little bit different. And this is where I said a couple slides ago that you're going to need some UL 1008 style device, but it may not be the BCELTS. The big sort of building scale transfer switches that tend to get deployed in generator-based applications, they actually fall under the same code by UL. They have a different name. They're just automatic transfer switches. This actually is a much more common application. So the way that would work is, yeah, you still have your breaker panel feeding in utility power. You have your emergency power coming from the generator. But instead of on a zone by zone basis, instead of being on the load side of the overcurrent protection device, the breaker, we're actually on the line side of it with our big honking transfer switch. This might be like 1,000 amp transfer switch that just creates a total critical panel. Now that panel at this point can be considered normally on style power. It's critical. It's always there. The transfer switch upstream of it is going to be converting between generator-based power or utility-based power, but this critical line here is always on. So we don't need a BCELTS to perform that behavior of switching between power sources. All we need to do now is override this lighting control when there's an emergency. So how does the architecture help us here? Well, we have our hot line. We're sensing that on the 924 device. When the lighting control closes in normal operation, we're just letting through critical power. We don't know where that's being generated from. It could be from the utility, or it could be from the generator over to there. And then when that sense line goes away, we just bypass our lighting control. We start ignoring that and driving that critical fixture to full on. So this is a generator-based system utilizing a transfer switch, which is very common, that actually uses UL 924 devices all over the place instead of the more expensive, more complicated BCELTS type devices. So this architecture is pretty common in things like hospitals, and there may be an inverter here as well in order to meet different parts of the code. But generally speaking, just because you have a generator doesn't mean you necessarily have to be in UL 1008 BCELTS land. So that's an important thing to remember here. As I mentioned at the top of this, the goal of this course is to actually give you guys an opportunity to weigh in on some of the topics that we're going to cover in an AIA accredited course. That's going to be a 30-minute half credit course that we're going to have ready in the next couple weeks. It'll go into more depth of those drawings. I'm hoping that we can do a couple more drawings, as well as having some animations to make it more clear. But if you do have questions, please feel free to throw them in the chat. As always, these drawings in some form or another are available all over our existing documentation. They exist in cut sheets and instruction manuals for the ELCD devices, as well as for the inverters. If you're talking about our mini inverters, there's even a couple more caveats about how various devices work in those applications. So check out the website. And as always, you're going to see an email coming from us in the next couple weeks that will be a follow-up that gives you access to this presentation, and it will be on our webpage under the knowledge section. So you can go and review this presentation, show it to your customers or other employees who were not able to make it. With that said, as always, my name is Evan Ackman. Greg and Matt are on the line with me today. We certainly appreciate everything that you guys do for us. And so all we can do is be here to support and assist you in any way possible. If you want to talk more about UL 924 versus 1008 and transfer devices and inverters, or anything that we do, all the way from the most simple exit sign all the way to the biggest inverter, please don't hesitate to reach out to us and let us know. We'll get on a webinar, or hopefully in a couple months show up live so that we can do some training for you. With that said, that ends the formal part of the presentation. Please have a good day and a good weekend.